How does GPT impact an operating system's boot process? Imagine turning on your computer and watching it come to life. The way it starts up is a carefully choreographed sequence of steps. Today, we will explore how a technology called Generative Pre-trained Transformer impacts this process. While GPT usually refers to a language model, in this context, it relates to a partitioning scheme called GID partition table. This scheme changes how the computer's firmware interacts with the disk during startup. When you power on your device, the firmware, either basic input-output system or unified extensible firmware interface, begins the boot process. It looks for the bootloader on the storage device to load the operating system. In older systems using the basic input-output system, the firmware reads the first sector of the disk, known as the master boot record. This sector contains the bootloader code that starts the operating system. Now, when the disk uses the GID partition table instead of the master boot record, things change. The GID partition table stores partition information in a more flexible way, allowing for larger disks and more partitions. It also includes a protective master boot record to prevent older systems from misreading the disk. This means the firmware needs to be aware of GPT to find the bootloader correctly. On systems with basic input-output system firmware, the bootloader must understand GPT. For example, Linux systems using the Grand Unified Bootloader version to often need a small special partition called the BIOS boot partition. This partition holds extra bootloader code that the system needs to start from a GPT disk. Without it, the bootloader cannot load the operating system properly. On systems with unified extensible firmware interface, GPT is the standard. The firmware reads a specific partition called the Extensible Firmware Interface System partition. This partition contains the bootloader files stored in a standard file system. The firmware loads these files directly, making the startup faster and more flexible. This setup also supports features like secure boot and multiple boot options. Different operating systems handle GPT differently. Modern versions of Windows, starting from Windows 10 and Windows 11, use UEFI firmware and GPT by default. The operating system loads the bootloader from the Extensible Firmware Interface System partition. If the bootloader needs repair or management, it is often done through special tools that work with the FI partition. Linux distributions typically use the Grand Unified Bootloader too, which supports both BIOS and UEFI systems. On BIOS systems with GPT, a BIOS boot partition is necessary. On UEFI systems, the bootloader files are stored on the FI system partition. Older operating systems, or those running on legacy BIOS systems, cannot boot directly from GPT disks. They relying on the master boot record and do not support the newer partitioning scheme. In summary, the GID partition table influences the boot process by requiring the firmware and bootloaders to be aware of its structure. On UEFI systems, GPT allows for a more modern and adaptable startup process through the FI system partition. On BIOS systems, additional steps like creating a BIOS boot partition are needed to boot from GPT disks. This change affects how different operating systems manage their startup, routines, and disk management, reflecting differences in firmware types and bootloader designs.